I'm going to be giving a presentation on paste printing and some of the derivatives thereof. It's a printing process that's been used mainly in the do-it-yourself community, hasn't been adopted very much in the commercial industry as of yet, but it'll be interesting to see where that goes. So here's a brief introduction of it. There's two major process variants. One is the syringe pump-based processes like frosting printers and mainly used for cake decoration, things like that. The other variant is inline pumps, which are things like either gear pumps or peristaltic pumps, or in the case of very large systems, concrete pumps for printing things like houses. Um, they're both a little bit different, but at the same time have the same end result. The material is pumped down into an extrusion system, which deposits the material onto a bed, very similar to a standard FDM type 3D printer. The main process parameters that really affect the part quality are things like paste viscosity. If you have a very viscous fluid, or a thicker paste that's almost granular like frostings, it becomes very difficult to get a good quality extrusion, and that's also a problem that's seen a lot in the concretes and those types of materials. The other thing is paste abrasiveness. If you're using very abrasive materials like ceramics, they will degrade the nozzle very quickly, and so you need to make sure that the nozzle is a replaceable component. And then lastly is surface tension, because as you're pumping a fluid, the surface tension is what's going to prevent it from dripping out of the nozzle when you're not printing. And to anybody who's ever worked in FDM printing, it's a huge issue when that happens because you end up with a mess all over the print. Some of the niche capabilities of paste printing versus other types of printing is that you can print with food. So that's how a lot of the, either like there's a pancake printer that recently came out. A few people have experimented with printing frosting on cupcakes, being able to do custom shapes. And then dough printing, there's a couple machines that can print pizzas by actually drawing the dough. So you can print like a heart-shaped pizza or something for Valentine's Day. It's silly stuff. Next one is ceramic printing. So clay, wet clays and metal-infused clays, sometimes used for jewelries. It's possible to do with some other methods, but if you're trying to do a one-off of a fairly complex part, it's a nice process to use for it. Concrete and cement printing, things like the stuff that people have seen a little bit in the news lately is people trying to build houses with a 3D printer. Really cool ideas, and gives some really interesting possibilities in the printing that you can't achieve with regular manufacturing. And then finally, liquid and curable part printing. So that's where part of my research goes in for my senior project here at OSU. We're developing a printer that can print two-part silicone. And it'll print that for making soft robots, and I have a little video on that later in the presentation. Materials, frostings, batters, doughs, that's in the food area. Wet clays, silicones, epoxies, concretes, basically anything that is a fluid-like substance, a paste or a fluid that can be pumped through a tube, you can basically print with these processes. The first of the case studies I have here it's a silly one, but it's kind of cool. It's Discover 3, or whatever the hell they want to call it, is a really cool thing that happened on Kickstarter. It's basically a syringe pump extruder printer, though it mounts to any existing 3D printer and allows you to print various different pastes and stuff. So one of their Kickstarter promo pictures was them having printed the Star Wars logo on a cupcake. And while that might not seem really useful, in certain industries, like if you look at when you go to Fred Meyer and you get a batch of cupcakes, they all have the same topper. That's because a lot of times they're actually using an automated system to do that if you're buying the big mass-produced ones. And those require very expensive dies to actually extrude the frosting. And if they want to make one off of somebody's name on a cupcake, it ends up being done by hand. So you can't really have it done, in an automated fashion, and that costs more money. So it'll be interesting to see if this gets picked up more by the commercial industry as opposed to just the consumer industry. The next one's concrete printing. This is a picture of a guy who built his own concrete printer and printed a castle in his backyard. I think this is awesome, and I want to build one of these, and I plan to build one of these at some point. It'll be when I own some land of my own. But it's a cool process because you can actually make some shapes that aren't possible with regular manufacturing methods. In terms of certain types of arches and things like that are very difficult to make normally, but with this it's very easy. And one of the big difficulties with concrete a lot is that most shapes with concrete are square, because you're using a huge sheet of plywood as a mold to frame it up in square. So curved shapes with concrete require extremely expensive, extremely complex molds and bracing systems to build. But with a system like this, you can actually print a curved surface. And this one, you can't see it too much, but in the columns on the spires and the edges of the castle there, you can actually see it's a curve. And that's something that's traditionally quite difficult to do with concrete. So this allows people to do that in a more user-friendly way. That said, there's still no commercial entities out there that have released concrete printers or provide concrete printing services. It's really on the do-it-yourself side right now. There's a few different research labs that have pulled some stuff together and made some kind of cool machines, but nothing is really commercial yet. So another one that'll be pretty interesting to see where it goes. And then this is the area of my research. For my senior project here at OSU, I'm developing a 3D printer to print silicone for soft robots. Right now, it's very difficult to make them. They require a lot of dexterity and a lot of work. Making a robot that big, which the part on the screen there is probably 2.5 inches long. And I was hoping to bring one, but I wasn't able to grab one in time. For a part that size, you're probably looking at 2 or 3 days of work to make. In terms of making the molds, which you have to make by hand, essentially, and then pouring silicone, which is really almost an artisanal process because it's so finicky to get it just right and get the mixes perfect. Then gluing the multiple pieces together, making sure the air chambers are the right size, poking little extra holes if you need to. It's really a difficult process, and the sponsor for the project that I'm working on for senior project, he is Dr. Yigit Manguch, and he works on these and really wanted a way to make them a lot faster. So that's what we're doing, and to see a little bit of what these little guys do, that's what these little robots can do, and that might not seem very useful, but it actually is really useful because you can do things like make grippers out of these that can grip onto a person without hurting them because there's no metal parts inside to actually cause pinch points, and they allow a lot more dexterity than traditional manipulators allow, and they act a lot more like organic forms, and that's kind of the kind of cool thing. And here's another interesting one. It's a little walking version of that same little quadruped robot, but there's a sheet of glass in its way, so it can't go under it. But because it's silicone and it's soft, it can make its way underneath the glass without actually breaking the glass or getting stuck. So it gets a little bit stuck there, but they figured it out, and then it just inchworms along. So some pretty interesting stuff. Right now, these take a very long time to make, and it's extremely manual process to make them. And using paste-based printers, it should make it possible to manufacture these a lot quicker and iterate research much faster. There's an external air pump in the case of this one. There's hoses that come out the back, connect to an external air valve system that's sending air pressure to each one of the limbs and then the center. What we're planning on trying to do is print it in a way where you can just stick the hoses into a set of holes that are essentially fabricated into the back of the part and have it work right away. The other uses for these are things like soft sensors, sensors that have liquid metal inside, so as you stretch them, they change resistance, and making biocompatible parts. Silicone is a biocompatible material, so it allows for making implants and things like that. By being able to print that, it'll reduce the manufacturing costs by quite a huge amount. First of the vendors, actually the only of the vendors that I was able to find that actually sells one of these right now is Structured. And they make the Discovery 3D extruder, which is a add-on to a standard FDM 3D printer that allows it to print with frostings, clays, etc. They recently did a Kickstarter campaign, and that's how they exist. But that also shows that there's really not that much industrial side of this right now, and I think that's something that there may well be, but right now it's still shrouded in industrial secrecy. And then big block of text, but basically right now there's a lot of work going on in the open source community, from the concrete printers to people building paste extruders to people printing frosting on their cupcakes and making pizzas on printers, and there's even a guy that made a machine that draws pancakes. Pretty cool machine too. But there's not that much being done in the commercial sector, and I think that'll be interesting to see in the future if the commercial sector picks up on this and really brings out some of the larger potential.